Okay, so I'm going to start by reading the answers to numbers 1 through 5 so you can know if you're correct and so you know which questions you need to watch. So number 1 is B, 2 is C, 3 is B, 4 is E, 5 is B. All right, so you can kind of jump to whichever part of the video you need to then. So looking at number 1, the greatest standard deviation. So standard deviation measures the spread, and it's in terms of distance from the mean. So for all of these are symmetric. So I know the mean for all of these would be right smack dab in the middle because they're all symmetric. So I want to look about which ones collectively have the points furthest away from the mean. So when I look at B, I've got 2 big chunks that are outside of the mean. All of the others have points right at the mean that would lower the standard deviation, or here it's evenly spread, so our correct answer here would be B. For number 2, so we're looking at the IQR. So IQR ranges from Q1 to Q3. On a box plot, Q1 is the beginning of the box, and Q3 is the, that's the beginning. Q3 is then at the end of the box. So I'm just looking at these values. So this one is at about, we'll say 3 is the beginning of the box. The end of the box is, we'll say, at about 19. So the IQR is going to be 19 minus 3, which is 16. So even if you said those were something slightly different, the answers are far enough apart here to where you'd be able to, the closest one would be 16. Looking at number 3, so all of the options talk about the shape of the distribution. So when I look at this, the shape is clearly skewed to the left. Okay, so that would be B. The long tail goes to the left. Right would be the opposite if the long tail were on the right. Normal is that bell-shaped curve. Chi-square is always skewed to the right, and uniform would be if all the bars were the same height. Looking at 4 then, so unfortunately anytime they say which of the following statements is true, you really do need to read through all of them. So when they're talking about serving all 60 of their employees, so just because it's from an observational study doesn't necessarily mean we can't use the data, so that one would be out. We also can't use it to prove or necessarily draw cause and effect because this was just an observational study, right? We didn't apply or impose any treatments. So not necessarily the information won't be useful just because it wasn't a random sample. The bank would have to use the survey to construct a confidence interval in order to estimate. So these two are kind of connected. So inference procedure is anything like a confidence interval or a test. Here we don't have a sample. We have all 60 of its employees. Anytime there's all of something, we're looking at the whole population. There's no need to do a confidence interval or a significance test because we have all the data. We do those things to figure out a claim about the whole population. We don't need to make a claim about it because we know exactly what it is. Okay, and the last one here, we're looking at the median of wait time. So I'm looking to see that there are 175 patients total. Okay, so I would want to think about, okay, well, what's half of 175 because that's where the median would be at. So when I look at this first bar, the height is 80. Okay, so if I think about moving from left to right, I've got 80 observations. That median then is going to fall somewhere inside of this bar. Right, so half of 175 is going to be somewhere a little less than 90. So the 90th observation would occur in this bar because this bar is about 50 high. So we know it's somewhere between 5 and 10, and there's only one choice between 5 and 10, so that's the only possibility.